Hello CS50, Introduction to Artificial Intelligence with Python. Why can we create a perfect AI for TicTacToe? Well, the game is basically completely solved. And how can we program this AI? Well, we use something called a minimax algorithm. And what this algorithm does on an intuitive basis is that we display all the possible paths how the game can play out. And then we assign values to each board state. For example, if we want to maximize our utility, we can assign a +1 to a winning board state, and then the computer takes actions in order to achieve this maximum board state by taking actions so that the other player who wants to minimize this value must take the minimum max action. So the other player has to comply to it. And if we have two perfect players, the game will always be a tie. So if two AIs play against each other, we will always see a tie. So we will take a closer look at the minimax function, which is always called before our AI makes its move. So first we initialize our alpha and beta. This is done for the alpha beta pruning. Then we will just return none if the board is terminal. Then we check which player we have. If it's player X, we call the max value function in order to get best action, and if it's the O player, we get the min value function. So jumping into the max value function, we see that we have our base case. So if we are at the end of the game, if the game is terminal, we just return none, which is our base case. Then we initialize the value, which is in the max value function minus infinity, and then we loop over all actions in all possible actions that we call with our function, and we return the value and the best action, which is here only placeholder from the min value function. So we go up here and we call this min value function, which is basically the same function, just not the max but min. As you can see here, we call here the max value function again, and so we return the next value. So we will assign our next value to be the higher of value and val, and if our next value is higher than the current value, we initialize the new current values. Then you see here the alpha beta pruning, which means if we have already the maximum, we will stop in order to make the algorithm faster and return value and the best action. So returning to run a pi, we will run our application, and it will start in a minute. Oh, so we have it. So our first game will be played as X, so we will begin here. We will place our X here, computer here. Okay, let's go up here, down here, and we will make a mistake and the computer wins. Okay, so let's play again as X. Now we will play a little bit smarter. So play it down here and here. And as you can see, we have no chance to beat the AI that we programmed here, or our minimax algorithm, better said. So play with O, so the computer is starting out here, and we will, well, only achieve a tie. Again, we will let the AI win here. Let's place it here, then there. Okay, so now we will lose. Yeah. So the AI wins the game here again. So let's start out again. We will place it here, here, and then yeah. So now something really weird has happened. Why hasn't the computer just put his circle on the left to make 3 in line and win this game? Well, this is because of what we talked in the beginning, that in our minimax algorithm we haven't put a discounted value on terminal board states that are later in the future. So the minimax algorithm doesn't take into account that it would be, well, let's say, more intuitive or smarter to end the game more quickly. And because we haven't discounted the values that are later in the path of winning, the computer doesn't care if he plays 100 actions or just 1 or 2 actions to win, for example. So he only cares about reaching the max or min state, but he doesn't care when he reaches. And this is quite funny from a human's perspective. For the algorithm or AI perspective, this doesn't really matter. So this was my solution to TicTacToe.